Hi guys and welcome to today's tutorial. Today I'll be giving you a look at the volumes application within the Leica iCON field software. So if I jump into my volumes application, we can see here we actually have a stockpile survey which has been completed. So what I'm going to do today guys, I'm going to show you some of the functions that you have within this application, like creating services among multiple types of actually volume calculations, such as surface to surface comparisons, surface to a predefined elevation, or just a generic stockpile survey. So I'll be running through those scenarios. So when we're within the volumes application, it's prompting us straight away saying select a surface or select new from toolbox. So we haven't got a surface already made. So the first step obviously would be to create one. So if I come into my toolbox, we can see we can select new surface. What I can do is I can define boundary lines and I can define break lines. So if I come into my toolbox, I can select create boundary. And if I select start boundary, I can select the line. So this has worked out well because there's already a pre-existing boundary line which has been surveyed. But again, it wouldn't make any difference if the line hasn't already been created. We'd be able to individually go around and select these points if we so wished. I can select stop boundary, toolbox, and create a break line. So this was the bottom of the embankment, and we also have a top of embankment. So if I select start break lines, I can select these lines here. Okay, and I can just fill the gaps. And I also have a center of the embankment as well over here. And I will just fill them in. Okay. And the advantage of using break lines is essentially if we zoom in here, what a break line will do is prevent any interpolation between the defined line. So if I had a point left or right of this line, okay, and I had a break line defined here, it will not let these interpolate in between. So it will basically hold this solid feature coming along when it's creating the surface. So if we look at scenarios such as creating surfaces over roads, where we've hard features such as top of curve and bottom of curve, which are clearly going to be strong defined lines, which we will want to see within the surface, these are instances where break lines would prove very useful. We can also see when we select boundary points or break lines, what it will do is by selecting the lines, we're actually selecting the points associated to those lines also. Now, again, we can see we have some outlier points, so we can select those individually. And once we're happy that we've all the points within the surface, we can go to Toolbox, End Surface, give it a name. I'll just call it Stockpile, and select green tick. And now we can see these blue lines are hard defined break lines, top of banks and bottom of banks. Okay, which gives us a really distinct looking surface. So I always like to zoom around in 3D and just inspect the surface. So again, we can see this hard defined line. Okay, and also on the center of the embankment. And so it's never a bad idea just to have a scope around and just make sure you're happy that it is giving you the sort of result that you were looking for. So if I go back to my top view and zoom back out, what I can do now is once we have the surface selected, because you can see it's in kind of like this purple blue color, we can go into Toolbox. And what we could do is we can edit the surface if we wish to change anything. You're not hold fixed to your first kind of go at generating that surface. You can edit it later. So if I just cancel the edit and come back in, we see now we have volume calculations. It's not grayed out. So if I can click in here, and this is clearly a stockpile. So I'll just look to create a stockpile survey. We can see there that we can add our expansion or our bulking factor for any swell. And again, there we're also displayed instantly our surface area meter squared, perimeter, highest elevation, lowest elevation, and balance site elevation. So the balance site elevation might prove very useful if we're actually looking to level out a site. So we could do a topographical survey, just including spot heights over the area, and quickly just create a surface over it, call it stockpile survey, and it will quickly give us a balance site elevation. So if we select green tick, we can call this stockpile. Okay, so that's our first form of survey done. And if I jump back out and I go into jobs, now if I look to do a surface to elevation, come back into my volumes, we'll see here now what I actually have here is a slab survey. Okay, and we can see here it's very defined. Now this could work in two ways. If we had an existing model or design for the slab, what it should be, we could import the design in as a CAD file, whichever format we have it in, create a surface over and do a surface to surface comparison. But if we know that the slab has to be on the exact same level the whole way around, what we can just do is a surface to elevation. We can see here we don't have any clearly defined boundary points, so we could create them if we want. Or if we're just looking to do a quick analysis, we can come in and select new surface, selection window, and we can start selecting all around our points. We can select green tick, and we can see here they all come up with the ticks on them to say they're going to be included in the surface computation. So I can then come up and select end surface, and I can call it slab as built. And what we can see here is because we didn't create a boundary or break lines, it has interpolated in between these areas even where we had no survey data. Now, for the purpose of this, I'm not really interested because I could just want to see where it's high and low relative to where I've actually surveyed. So what I could do is jump into my toolbox, go into my calculate volume, and go into surface to elevation. And if I knew that this whole slab elevation was meant to be 55.985, I could select green tick, and I could have a predefined tolerance, and I could say I want it all to be within 5 mil. I can select into my cut fill map, and we can clearly see areas which have been highlighted. Okay, blue depicting low. The deepest blue we can see here is as low as 95 mil below a predefined elevation. The highest red elevation climbs to 279. Again, I could look into this in 3D, and we could kind of see we have our deepest blue area over here, and we have a red spike here. And this could actually just be an outlying point. So we can see here, if I zoom down, I can see I have a single point which spikes up. So again, that could have been an error within the measurement. Again, because you'll probably notice something sticking up 279 mil on the slab anyway by eye. So if I jump back to the top view, and kind of the main advantage is the fact that the different jobs you look to try and do, you can have predefined tolerances. Okay. The surface to elevation command will also work really well if you're looking to look for cube volume to fill. Okay, if you had a number of slabs to pour and they all have to come to the same elevation. So we can see there we have our cut and our fill values displayed, and we have a number of the same kind of parameters that we would see with the stockpile, like our balance site elevation, lowest elevation, etc. Okay, and then I can select green tick, and I can call this one surface to elevation. Okay, and if I come out now, and I go into my jobs and look at surface to surface, we can see here we have multiple types of surface. What I'm going to take is that my red is actually my design surface. So what I can do is I can create two surfaces. I'll create the first one, create a boundary, a start boundary. I can select our line here. And next I can use the selection window command. And I can select all around these points till they're all covered. Select green tick, end surface, and I will call this as built. Okay, I can see there I have my as built created and I have my design cutting through it. So what I want to do now is create another surface of my imported design. And select new surface, start boundary, select these points, and I call this design. Okay, and we can see there now we have our two surfaces which are intersecting. If I select one of them has to be highlighted first. I select design, and I can now come in and select calculate volume. I can select surface to surface. My existing surface I will select as my as built, and my design surface I will select as my design. We'll select green tick. Again, it is possible then to also select the same surface twice and just do an offset if we want to just know what the block volume is, either upper or lower of a design or of an as built. But again, I can be happy enough. I can just go with these. I can again set my cut fill tolerance. I'll up it for this one just because I know there's a greater exaggeration. I'll define it as 100 mil. And you can see with the same sort of value, but you also have now a percentage of overlap because it can only do the comparison in areas of the surface that actually overlap with each other. So if I select go into my cut fill map, we can see here it's actually cut off the edges because I hadn't got a comparison surface to compare in these areas. Okay, and we have the same sort of values that we would have seen in the surface to elevation cut fill map. And again, we can select green tick, and I can define this as surface to surface. Okay, as we're all aware then as well, we will be able to produce reports. Okay, So I could come in and I could do my surface elevation for an example, and I could select here and go to volumes, surface elevation, and select green tick. What we would then be able to do is come in, have a look, and actually see all those bits of information that we've seen before, except just kind of expanded out into greater detail. Kind of advantages as well of kind of doing these reports is that, again, it's all dated in time, when it was first accessed and when it was last accessed. So you have a full record there. So we can see 2D image for existing as-built survey, 3D, and then also our foot-fill map, okay, with a predefined tolerance of 5 mil. It'll give us everything in terms of kind of our surface points, our boundary points, everything will be recorded. If we're using the GPS for any of the as-built measurements that we used, it will actually display the 3D CQ, our 3D corner quality, for how accurate the points were that are included in the as-built. Okay, so guys, I hope that tutorial was useful. If you have any other questions relating to the volumes application, please feel free to get in touch.